Okay, so what we're going to do is a new way of analyzing our data using the guess and check method. So what you're going to do is go up to the top left here. So you're going to go to Desmos, and you need to log in if you want to save your work. So create an account if you don't already have one. But up here at the plus sign, you're going to add an item, which is going to be a table. In the first column, we're going to have the note number, and in the second column, we are going to have the frequency, and you're going to put your data in. So maybe you got 250, I'm sorry, for note number 0, you got 256, and you can just keep putting your data in here, and you can use tab to go between the fields. So for note number 2, maybe you got, and this is just made up data, this is not correct, maybe you got 290, and eventually you got up to note number 12, and let's say that was 500 hertz or something like that. Okay, so down here in the bottom left corner of your table, you can click and it will change your scale to show the data here. All right, so now we're going to try to guess and check a mathematical model. So we're going to guess a function. So because musical notes, the frequency doubles every octave, something that keeps doubling, the best guess is that it's somehow an exponential function with a base of 2. So when something keeps doubling, that's a good guess. So we're going to write a function y equals, we're going to put a times 2 to the power of, and you can use the shift 6 to get the caret, and we're going to put bx. Okay? And what we're going to do is we're going to guess b and x. So we're going to add sliders for both of them. To get you started here, I'm going to click on this little 10 here, and I'm going to say that A goes anywhere between 0 and 500 by 1s. So you'll be able to move the slider to make A anything between 0 and 500. And then to help you on B here, B is actually going to go somewhere between 0 and 0.2. And let's go by 0.0001. So we'll make fairly small increments. Okay? So there we go. And then what you can do is you can adjust these parameters, A and B, until you can get the line, this line right here, which is black. And you can change the colors of these, by the way. So if I click on this table here and hold it down, I can make my data red. The point's red. Oops, there we go. The mathematical fit, which if I hold down right here, I can make a sort of a dash line. And so your job is going to be to adjust these sliders until you can get the best fit possible. And the best fit is the line that comes the closest to as many points as possible. And when you can fit as many points as possible, you will then know your mathematical model. Y is the frequency. A will be whatever this is. So if this was my best line, I would say that the frequency equals 260, because that's what A is, times 2 to the power of 0.078 times x, which is my note number. So we're going to guess and check our math model by assuming a functional form, an exponential function with a base of 2, and then adjusting the parameters A and B until we get the best fit. When you get that, I would like you to take a screenshot of this screen, which shows over here your fit parameters as well as the graph, and you are going to insert that into your spreadsheet as evidence that you have completed this portion of the graph, and then you will have the mathematical model. Okay? So that's the idea.